Thank you, everyone. I promise I won't take you away from the pizza for too long. But we have the solution to all of the problem we've been talking about. It's called the AI. It's a lie. I'm not going to sell you AI first. I'm going to talk you about the human-centric approach on AI or LLM, or as I like to talk, is AI second. You're going to hear a lot of talks around any security conference. We are an AI first company. AI first, AI is going to solve the world, BS. All right. We still have the same problem, it's just a technology. So today, I'm going to ask you a little bit of participation. You're going to be the population eager to use AI. And at a clue, and you're going to see the clue, you're going to ask me, can we use AI now? And you're going to see why. But I've been in this industry for quite a while. Yeah. Here you go. And I've seen things in vulnerability management, software security, traditional vulnerability management. Who can recognize this? Who is all like me? Exactly. Blade Runner, I've seen things that you human can't even imagine. I've seen security team raising vulnerability problem to engineers without even telling them what vulnerability was, but hey, you have an SLA of 2 days to fix it. And now the latest trend is, hey, I'm gonna throw all of my SIEM, all of my vulnerability into an LLM, and guess what? He's gonna figure out the answer that we've been searching for 20 years because LLM are smarter than human, right? No. That's good. Excellent. That's the answer. Because bad data in is equal bad data out, and probably you're going to get frustrated and kickflip your laptop back. So we don't want you to destroy your precious company property and backflip. As you might have imagined, I like to do security with a smile because security is heavy enough, and if we don't use a talk with memes, we get depressed. So let's all have a smile about this. A little bit about me, as Sam has nicely spoken. Been doing digital transformation for AWS, HSBC, most of the modern banking world. And I've seen now this trend of LLM trying to replace human. I think that's idiotic. And I propose a second approach to LLM and AI in general. AI is a tool. Let's use it as a tool. Otherwise, we become the tool. And I promise no LLM was hurt while doing this talk. Maybe, but we're going to offend some LLM. I'm not going to talk about Phoenix at all. Phil, my sales guy, is there. He knows everything about security and about Phoenix. So he's the man to talk after for anything about Phoenix. If you haven't registered, please quick scan of the draw, and we're going to go fast on that because I see pizza coming. So we're going to look at some of the topics that Anand has introduced, like how to organize things and how to basically link your software supply chain to your runtime, how to figure out who does what where, and is it important. And just after that, well, maybe we're going to prioritize it first. And after that, we're going to apply in step number 3, LLM. And we're going to see how we can use agent and specific session of LLM and specific feature of LLM in an intelligent way. And also I'm going to tell you the idiotic way to throw all of your vulnerability to an LLM and get the wrong answer. But it's going to be a very smart wrong answer. That's the important part. So hands up if you believe your company has a functional vulnerability management program. Okay. It covers all area, all scope of vulnerability, and you have all assets figured out. You attribute the right asset to the right team, and they operate continuously. Okay, we don't believe you. Let's move on. So I want to take a step back a second and say I'm old. So I've been developing code since assembly and COBOL at some stage because banking world has a lot of that stuff. And we've been on a journey on an evolution of application and how applications were built. Back in the days, 2015, the applications were a little bit more monolithic, were a little bit more on-prem, more simple, less attack surface. You take it to today, you have application building containers shipped. We have software coming from every part of possible imaginable world. TJ Action was an example. Any Log4j or open source vulnerability that you've seen is because a package is contained inside a package, this contained inside a package, and we don't know where those packages are coming from. We just adopt them blindfoldly, SCA for anyone. And then we have cloud security vulnerability, and now we added LLM into the mix. So we're rushing through the future without having fixed the problem of container code and cloud. So in this word, I feel you, because I've been burned out. I had a team that was maintaining 7,000 devs, and they were developing even faster than what Aman was mentioning, even 100 releases per day. And then you had teams releasing every 6 months. And how can you give them a policy to say, hey, you need to fix it in 2 days if the first release is in 6 months, right? So word in software and enterprise is messy, is slow, and is painful. And we're not getting any better, because from 2015 to today, we have 300,000 vulnerabilities. And if we project it to the future, in 2031, we're on a good road of 1 million vulnerability. So LLM is going to fix all of our problem. Well, it's going to also cause a problem, because we're giving an automatic code generation tool. And Aman has made a perfect example that it terrorized me because I haven't thought about that one, of an automatic code generator that can look at all your files. Before time, as a security professional, we were terrorizing of giving a software completely free access to our machine and all of our files. And today we call it MCP, or an LLM with access to all the system. And as a security, we're pushing that. So old man rant, but maybe let's take security carefully. But in general, AI is going to eat the world. AI is going to eat the security world, because it's going to develop fast. And as a CEO and other CEOs are looking at their organization and saying, how can we develop a 2x speed or 3x speed or 10x speed? But also attackers are developing LLM to actually find bugs and generate quickly code to actually deploy low-hanging fruit. And that's why we're seeing vulnerability exploitation time going from 15 days to 3 minutes, from declaration time to exploitation to a functional exploit being generated. And also we're seeing every possible developer in the world, or bug bounty in the world, saying, hey, I can throw an LLM to Kerr and generate code. Kerr hasn't accepted a bug bounty report, and I had to put star because to keep it politically correct, the answer that they've given them. But the answer that LLM generate are very well thought through. So it requires analysis, and every single release or every single bug bounty report that Kerr has received, an open source project with a bug bounty attached, a very well-known open source project, was completely BS, but very well written BS. So let's use a tool in a useful way. One of the challenges we have, and I'm going to take a step back, is we keep on treating software between pre-built file or pre-deployment and runtime as two different things. And we treat this organization and this word as two different words. And that's wrong, because the first things we do is we throw a bunch of scanners, SAS, Dust, SCA, supply chain, to developer in a CI/CD pipeline to break the code. And that's the way we say security is developer friendly. That's not the way security is developer friendly. That's developer unfriendly. And the alternative is a vulnerability management program that is a glorified dashboard that makes any executive relax. Hey, we have visibility on everything that our code get written, and then that vulnerability is actually important, get buried in 3,000 lines of code. And that's seems science fiction. Verizon data breach, the API that got breached was vulnerability number 3,000 in the backlog of that team. So it was raised, yes, but it was buried in a backlog of useless stuff. And then as soon as a breach happens, the executives say, how could we miss this? We have invested a lot in this dashboard, right? Dashboard doesn't mean action. And I think this year has been a little bit better, but we've seen major top-line vulnerability, or as I like to call it, superstar vulnerability. And as Anand said, can you just go and answer the question, do I have Log4j? Do I have Kerr? Do I have HTTP2? Do I have any of the team city. And visibility is important because answering that question and being able to remediate that vulnerability quickly, or at least notify the team quickly on the superstar vulnerability, will make you superstar towards your board because you have an answer quickly, not in 48 business days, with holiday included. And it's going to make you maybe better than the other people that are doing this in spreadsheet. So the problem that we're trying to fix is not how many problems, how high and how low, but who does what, where, and how important it is. But most importantly, can we apply LLM or AI now? So you're going to see this clue, and I want to hear from your aspect, can we use LLM now? Let's try it. Come on. No, can we use LLM now? Yes. All right. No, the answer is no, because if you just take a list of vulnerability, and I encourage you to do so, and you put it in your favorite LLM tool, DeepSeek, ChatGPT, Cursor, whatever tool, and you say, give me the smarter way to fix this vulnerability, terrible data in, I'm just going to call it terrible data in, plus an input equal very well taught terrible result, right? Has anyone in the room tried that? Very well taught suggestion. And I have example there, so if we have time, I'm going to show you some example. But what I want to hammer is, can we use LLM now? No. Let's prioritize, let's contextualize, let's get to the data quality that we need, and then apply LLM. So no, I'm sorry, we can't use LLM now. Because, well, I'm going to lie, we have a quick fix about it. No, there is no quick fix about it. There is good engineering. So let's do good engineering. So first of all, vulnerability management, on the modern vulnerability management, is application, infrastructure, and cloud security built all together, because there is no anymore boundaries between those things. And any organization that keeps on saying there is a boundary, there are teams, there are different time and different methods to fix these things, it's a lie. Because as a hacker, I don't care if I'm going to attack the application, the supply chain, or the box where that thing lives. I'm going to find the easiest path to reach that problem. And I'm not going to argue with management, but Joe from platform team hasn't patched the container because he didn't know that that particular vulnerability was included in the container that was coming from a piece of software that was an open source organization. Again, who does what where? And the answer is, as well, the first part of the answer is prioritizing is not that hard. We have a very simple way. So if we take the whole list of vulnerability, the one that are really important is just 5%, 1%, your opinion, the one that actually are well known, 25,000, the one that we see on average on our clients. So it's not anymore that scary number of 263,000, because that's included things from 1993 onwards, vulnerabilities. So we don't care about those. The only one that we care about is 25,000 vulnerabilities that are currently active in the wild. And of those, a fraction of them are actually exploitable, are actually used in live, are actually reachable. And the one that we need to care about are a single digit. So let's see how prioritizing things in two different landscapes, because I've been keep on saying application security and runtime needs to be correlated together, but they're not the same beast. In order to prioritize things from a software perspective, the important things is, do you have a fix available? Is that particular problem reachable? Is that particular problem or library deployed anywhere? Those are the important questions to ask when prioritizing software supply chain vulnerability or any vulnerability in a particular piece of code. What in a cloud environment do you have a fix? Is that thing deployed in prod? Is that thing exposed? Is that part of a container skill set? Is that container even running? Those are the important things to ask your vulnerability management program. And if you don't have a vulnerability management program that answers those questions, you have a spreadsheet. And throwing a spreadsheet to an LLM will not solve your work because it doesn't have the intelligence to look at things. So if you want to take a very simple answer to what's exploitable, what are the vulnerabilities that we need to take care about, if you just look at the bug bounty active vulnerability, those are 17,000. So we go from 26,000 to 17,000. GitHub active and verified exploit, that's 9,000. Those are not the hidden zero-day vulnerability, but those are the low-hanging fruit that anybody with an automation will try to throw your system. So if you have one of these, please don't burn your money on bug bounty on those things. Please don't give this away. Just throw a scanner, identify an important one, fix them, and then focus on the bug bounty and other things that only people with intelligence or eventually LLM in the future could find. If you go down the line again, verified exploits, CISA-CAV, who heard of CISA-CAV or VUNCHE-CAV or manually verified exploit? Those are good CTI, those are good elements, include them, they're freely available for everybody. EPSS above 0.36 right now because we updated to version 4 and we made it a little bit faster with data and intelligence. Those are, it's the threshold that we say that a vulnerability has actually the probability of exploitation in the wild in the next 30 to 14 days. And then, is that asset reachable? Is that asset exposed anywhere? And reachability is going to have different terms. So when you look at the exploitability, who has a definition of exploitability in the room? Who can tell me what's a vulnerability that is exploitable? What does that mean? Do we have a single answer? Reachable is one? Sorry? Easy to break in. Yes, you have a well-known exploit available in the wild. Is that being used? All of the above. All of you are right. So is that popular? You have some free and open source available option to see if a vulnerability is popular. Was this a 0-day? Likely is it's going to become an exploit. Is this automatable? You can look at your attack vector if has specific characteristics. And that's where LLM are excellent. And we're going to see an example of how you can use one of the LLM agents that we have to calculate prediction above and beyond EPSS. Is it exploitable? Is it exploitable in the wild? Do we have evidence of that? Do we have good available CTI? All of this will drive down your vulnerability exploitation. There is reachability analysis that we're going to cover on one in a second, because some of this information are not applicable for SCA and container vulnerability. So we need to look at the problem of container vulnerability and open source software being built in container in a slightly different way. Also because of scale. So if you want to impress your management team, you give them a pyramid of metrics that you can use. So if you're maturity level 0, you just react on what the scanner says, on CVSS, on basic metrics. And then you're going to start evolving your metrics. You're going to start looking at severity. You're going to look at actual exploitation. You're going to look at the stuff that is actually reachable. So you mature your organization. I'm not asking you to go away from this session and say, we're going to be the most mature organization in the world from tomorrow because any management team was going to laugh at you. But you're going to build a roadmap to a certain level of evolution. Because we want to move from raw vulnerability data to enrich vulnerability data with context and with reachability, because that we can feed to an LLM. So, big question to you. Can we use LLM now? No. It's ownership time. So let's talk about ownership, because what's the point of prioritizing if we don't even know who owns that asset? Where do we raise that vulnerability? Who's going to fix it? Joe from platform team or Dave from software team? Well, if nobody knows who owns that specific box, everybody's going to point the finger at the ceiling and say, let's figure out who owns this. Guys, who owns this container? Like, in the meantime, the container get exploited or the software get exploited. Like, that needs to be solved before a vulnerability happen. Owning the right problem to the right team is a very important problem. And we have way to do that. So the way to do that is, again, thinking about context and thinking about left and right. So who owns the platform sometimes is a different team that who owns the software in the left, and software has different stage. So answering the question who owns a container is a very complicated question, for example, because the container could be the OS, the base image that get generated, that could be platform team. The software that runs inside the container, that could be another team. So it's a complex scenario. And if we raise SLA for a vulnerability in a container that a platform team can't solve, we're just gonna annoy them, to just be polite. And the other way around, if we raise a vulnerability of a cloud solution that the software team can't do anything about it, we're gonna annoy them because they can't do anything about it. And you know what they're gonna call that? False positive. And it's gonna drive us mad from a security perspective, because that's a true positive, but it's just false attribution. So we also need to teach developer to tell us we don't have a good CMDB. And as a security team, unfortunately, are forced to tell them, well, tell me what you own. And they're gonna say, well, I don't know. So that's a conversation to be had before or with your vulnerability management program, because anything that doesn't have ownership in a vulnerability management program is going to just create nice, pretty dashboards that are giving you prioritized vulnerability, but they're not actionable. And no LLM in this world can give you that. It's a collaboration between security and engineering. Again, I'm here to demystify and not give you magic security dust. If you want, I have 3, you can try to sprinkle on your SCA or your dust and see if you can find vulnerabilities that are actually exploitable, fixable, and owned by a specific team. Believe me, you don't, but you can try. So I'm going to go quickly through this, but basically understanding how a software supply chain is created, how a specific software, which app gets built in which container, which library get loaded in which particular base image that get loaded in where, is the answer you need to answer, for example, on container vulnerability and SCA vulnerability. And that's even more important if it's exploitable, because if it's reachable, highly likelihood that that vulnerability is going to be exploitable. And this is a very hard problem to solve from an engineering team. As soon as you give an engineering team an SCA vulnerability or a container vulnerability, he needs to do this similar diagram to understand, do I even own it? Is it coming in the container? Is it coming from the base image? Is it coming from the repository? And who owns the repository? And understanding which app is built where, or is it in the image the problem? Is it in the base image the problem? Is it in the origin that I'm download from a specific repository somewhere else? Or is it in the build where I include my SCA vulnerability or my open source vulnerability? Every time we raise a container vulnerability or an SCA vulnerability, this diagram needs to appear in the head of a developer. And if it doesn't, he needs to build it. And that takes hours. And that takes a lot of investigation. That takes a lot of decompiling, especially if the container has been already built. That's where we specialize with Phoenix, and that's what we obsess, because that's an answer that prevents burnout. Understanding who does what where and trying to separate the left from the right or making it seamless is what saves engineering and security a lot of fight. And then you can start talking about SLA. I'm not going to go to the detail. We can maybe discuss in the break an example of that and how the 4 reachability analysis exist. And for the first SCA vendor or any vendor that's going to come to you and tell you, we have reachability analysis, just to annoy him, ask him, what of the 4 reachability analysis you have? Which one of the 4? File level reachability analysis, build level reachability analysis, container to cloud reachability analysis, network reachability analysis. Just to annoy it, just to make the SCE work a little bit harder. So let's talk about LLM. Let's talk about AI and how we can take a basic risk approach to vulnerability and how we can tie all these together. So the question you want to answer is really, how do I go from tons of vulnerability that I have to the one that are exploitable, weaponizable, actually reachable, deployed to production, and actually important? That is the funnel that you need to look at. And then basically go from a very basic CVSS, that's where most of the organizations start the journey in vulnerability prioritization, to a journey where you consider likelihood of exploitation, reachability, and business criticality. These are the answers that you need to answer to say, what is the risk of a particular problem that I have? And looking at your work, still look at which business application you build and where you deploy it and who owns it. That's the other answer that you need to answer with a vulnerability management program or tool. And all of the things we discussed can feed into risk. So we're not reinventing the wheel here. We're just trying to answer with a single number or with maybe a couple of variation of that number. Is that problem something we need to consider, or we can cancel it and say no to that particular problem? That's a very hard thing to say in security. Don't look at that. We're very good at saying, look at that critical problem. We're very bad at saying, don't look at that because it's not reachable, it's not exploitable, it's not there. That's why nobody likes vulnerability management, really. And what impact does it have? And that is the context. So with that, it did a modeling time, or LLM, as other people talks about. So a little bit about how we approach this problem. We haven't approached this problem in any other different way that human would approach this problem. So we look at the problem of, we need to have the right data to understand a vulnerability. Is it a problem or not? That's the first agent that we have. Then we're gonna just look at all of the context with all of the vulnerability you have in a particular deployment scenario on a good data set where we have already done prioritization, contextualization, and so on. And then in this scenario, can we exploit it? In this particular situation, can we exploit it? And then at the very end, what is the best path to remediation? So this is what normally goes into the head of somebody looking at a set of vulnerability and understanding or trying to analyze, is it important? Is it mine? Is in this particular context exploitable or not? And then how do I fix at scale? Otherwise, we're back in the middle age and reacting on any single vulnerability that comes at us. And on some way, if you have a very small code base, it's way easier to actually just fix all of the problems as soon as they come up. But as soon as they become in the hundreds of every release, as soon as the code base becomes bigger, go in this journey. I'm going to just quickly touch on how we deploy the agent. So the researcher is going to spit out a vector of analysis. That's where we apply an LLM, because LLM are really good at understanding CTI intelligence and creating a vectorized information of vulnerability that then we can use in the next agent that can tell us the root cause analysis, particular threat attack scenarios. And then finally, in the remediation agent, we can look at, hey, in this particular scenario, how do I fix it? What is my best path to remediation? Do I fix the container? Do I fix the library? Which is the library that's going to give me the biggest bang for bucks? And if I can't fix it, can I deploy WAF rule or any rule that's going to enable me to do virtual patching? Only if that thing is actually running behind a WAF. So that is why the context is important. All of this is LLM, but LLM applied when we have the right people that knows the right context, that where we can tell to the right people, this is what you need to fix. There is no point of raising a WAF rule to a software engineer that doesn't have access to the WAF. So the three problems that we explored before are absolutely mandatory before we apply any LLM. And don't believe any other company that tells you LLM is going to fix everything else, and then we're going to apply the whole context, prioritization, attribution, because they're only going to try to solve one piece of the puzzle that is the last piece of the puzzle, not the first one. This you can even forget. You don't need this. But the first part you need. Prioritization, attribution, you absolutely need. This is just to accelerate vulnerability resolution and to help engineering team to 10x their time. But you need the first part. Otherwise, who are you going to raise the vulnerability to? Is that vulnerability even reachable? You've done an analysis of 300 vulnerability in a container that is in a repo or in an image or in a registry that is not even running. What's the point, right? Why are we wasting tokens in an LLM to do an analysis that doesn't matter? And I know it sounds boring. I know it sounds not cool, but I'm trying to save you money and time and reputation, because as soon as we start telling engineers another answer, another false positive answer, we erode credibility. And that's what's hurting DevSecOps or security talking to engineers. We need to talk with clean data, and we need that collaboration to have clean data. So can we use AI now? Yes, we can. So what we did with the first problem, the researcher, is looking at, for the vulnerability where we don't have reliable data, can we understand the DNA characteristic of vulnerability that's going to turn into a ransomware attack, an exploitation? What are the things that turn something into an exploit? What are the patterns? What are the characteristics? What are the DNA analysis? Is this kit going to turn bad, or is this kit going to turn right? Right? So first of all, we need to solve a problem. It's a data problem. And we don't have enough data about vulnerability. We have CVE data, and then we have CTI, and we don't have anything in the middle to link these two things. So we take CVE, we go to MITRE through CWE, root cause analysis, threat impact, CAPEC, TTP, and then we're going to lead to threat actor. Those are basically trying to simplify this diagram. We're looking at the CVE, the vulnerability. What are the characteristics that this vulnerability has that threat actor is going to use? And then we start looking at, are there any characteristics of this vulnerability that are more likely to be used in particular data set? And it's going to become very apparent in a second. Now, CVE we have for container, we have for SCA, but for our code, we have CWE. So this methodology enable us and anybody that use this methodology to basically take a CTI-based or a threat-based approach, regardless if we're talking about patch a server or my code, is it going to turn into something that's going to be exploitable? So it gives a single language of exploitation. And this is what in security we've been talking about since forever. So an example of this journey is this one, and I'm going to give you access in a second. So if you want to test it, we are the only security company that has made their LLM and their agent available, so you can test it before you buy it. I'm joking. Yes, it's open source. You can throw basically vulnerability, your threat modeling, your threat attack description, and all of the vulnerability that you have, and it's going to spit basically the attack vector and the enhanced description. And we want to be able for everybody to start talking about this. And the only way we could do it, open source it. Have a play about it, capture the link, the book, explain the journey, the methodology, and the data set that we used, that I've used to actually guide the research team. This is a shared research right now with the North Carolina University. We have a couple of PhD working on it, plus Yahoo team. And we're going to make a little bit of this open source available. So we're going to enrich, and basically we rewrote the entire MVD to fill the gap of that 50% of vulnerability that weren't basically categorized with methodology of attack. And fundamentally what we did is, can we create a data set of common vulnerabilities similar to OWASP top 10 that enable us to characterize the vulnerability in the MVD or whatever we can see? And then we said, in the National Vulnerability Database, or all of the vulnerability that we have available, what are the common characteristics? If you look at on the right, they're fairly distributed. So we don't see any pattern appearing. So we start looking at, is the pattern between different years going to change? Yes, we start seeing the distribution of problems start changing. Cross-site scripting is basically slowly going away as a problem. Remote code execution is staying, but denial of service is slowly going away. And then we answer the very important question: can we apply this to ransomware? So we took zero-day vulnerability, or the well-known vulnerability that's been disclosed, bug bounty, ransomware attack, and say, out of this, what are the trending, what are the patterns that are more frequent? And at this point, we start seeing pattern emerging. Remote code execution is something available and reachable from external and from remote. Can I execute code? Yes. Buffer overflow, can I bridge basically gap in memory that's going to enable me to go move between programs and maintain persistency? By the way, all of this data is available to play. So we publish all of the data behind this intelligence on the website. So go and play with all of the data set we have available through our CTI. But fundamentally, we start seeing as well, 0-day was probably, remote code execution is very apparent throughout all of the years, throughout 0 days. And then we start asking the question, ransomware attacks. First of all, what is the frequency of ransomware? And can you notice who has the biggest attack surface? Which vendor has the bigger attack surface? Microsoft. Why? Because everybody's using it. Everybody has a Microsoft product. So as a ransomware attacker, I'm going to develop the version for Arch Linux, or I'm going to develop the version for Microsoft Windows. So programs and these are actually, we actually embedded that in EPSS. So if you have a particular program or if you have a particular version, those tags are actually part of the EPSS dataset, and we use the same logic as well here. But I want you to focus on the right side. Again, we start seeing the memory corruption and the remote code execution as pattern appearing. And over and over and over. So basically we took this and saying, can we use this as a prediction scoring or as a way to determine which threat actor is using which methodology, and created basically a data set that enable us to predict which vulnerability will lead into a ransomware or into a potential exploitation together with all the other factors. So we did this with LLM because this is a classifier problem, and LLM are really great at looking at a big data set and reclassifying those vulnerabilities into something that has a lot of context. This is where you use AI in the proper way. And this is the work of the researcher that's going to enable you to create, basically, regardless if you have vulnerability without this information, this creates this information. And we can use on CTI. Now, one interesting thing was bug bounty, where we had divergence. And bug bounty has maybe a biased approach where the common vulnerability normally are not being published as part of the bug bounty, but the really hard one to find are published as this bug bounty. But that's the only data set and the only place where we saw divergence, where we didn't see a pattern appearing as the other pattern that we've seen in the other attack, like remote code execution on CISA or verified exploit, or all of the GitHub with an exploit available and verified exploit. Again, remote code execution appearing over and over. So in conclusion, I hope you start creating a more critical thinking about LLM. We can discuss more about throwing all of the vulnerability and what the result of those vulnerability in an LLM is and how those are going to point you to the very wrong direction. So what I want you go out of this talk with, in a way, is use LLM and AI in the proper way. And for every company that come at you and say, we have the answer is AI, just call it BS. Thank you very much.
Thank you very much, Francesco. Right. Thanks for an awesome talk. Right. I think we have time for one question before we go into pizza. Anyone has questions? No? Okay.
Isn't the problem with Microsoft that it has a heritage of DDoS, which apparently stands for down and dirty operating system?
Well, Microsoft has an enormous attack surface to maintain and a lot of legacy software to maintain. And no matter what you're trying to decommission, airports still use Windows 95. and they pay a lot of money for those versions to be maintained. And regardless if Microsoft doesn't maintain anymore, another software house will try to maintain it and patch it and do something about it, because it's really hard to unhinge this software from specific system, unfortunately. Yeah.
One second, I'll bring your microphone.
But I mean, don't you think that, for example, over time, Microsoft, even though they're trying to maintain like as much as possible, they become in some ways, in some areas of cybersecurity, they've started to become a little bit complacent sometimes. Don't you think so?
No, I think they got way better. They got so much critique, they got so much attack surface that they got a lot better, but they have a lot of surface to target. So they're getting better at publishing vulnerability. They publish 70, I think, fixes every week or so. Patch Thursday is a thing. And we got way better at patching things. Right now, the attacks that we're seeing, Log4j, Spring for Shell, TJ Action, all of these are coming not from patching, not from Microsoft, but from other attack surface, because luckily we got better at fixing and patching things or automating that element. The problem that we're facing right now is container being built from somewhere else, because that's the next frontier of the hard things to solve and do. It is first party. As soon as you adopt it in your codes, I think it's first party. I think it's your problem. It's third party library, but as soon as you download it, I still consider it as part of my code. Yes.
Thanks very much, Francesco.